What's up, everybody? Today we're going to go over 6.1, the law of sines. This is part one. So, basically, the law of sine is a ratio that represents or that relates the angles or the three angles of a triangle with the sides, ultimately creating three ratios that are equal to each other. So this is ratio number one, which is equal to ratio number two and ratio number three. So kind of think of it as the Pythagorean theorem. The Pythagorean theorem is a relationship between the three sides of a right triangle. Here, the law of sines is a relationship between the sides and the angles of a triangle. Okay? So, and more specifically, an oblique triangle, which is actually right there. I was trying to find them in the notes, but I don't see it. Now, in order for you to be able to use the law of sines, and this is very important, you must be given one of the three ratios to apply the law of sines. If you're not given at least one, then you're not going to be able to do this. Okay? All right, let's go ahead and look at a couple of examples. So question number one, or actually our objective number one, is going to be to use the law of sines to solve oblique triangles like side angle angle and angle side angle. We're going to solve the following triangle. Make sure that you're rounding to the nearest tenth. All right. So in order for us to solve this triangle, we need to find every single angle and every single side. So we're missing angle H, which means we're missing little h. We do have K, but we're missing little k. And we do have little p. Okay. Now notice that I'm not using A, B, and C. It doesn't really matter. The letters don't matter. If you do want to switch the letters, feel free to do it. It doesn't really matter. As long as you understand that the top number represents the side, and actually let's go ahead and write that down. And the big letter represents the angle of the corresponding side, or the angle that is right across that side. Okay, let's actually across each other. Okay, so the top is the side, the bottom is the angle, and it's basically the side and the angle that are right across each other. So let's look at this example. Let's create our first, actually before we do that, we can actually find angle H. Remember that every angle of a triangle adds up to 180. So in order for us to find angle H, all we got to do is 180 minus 108 and then minus 38, which essentially gives us, and I'm going to write that there, it's 180 degrees minus 108 and then minus 38, which essentially gives us 34. So angle H is 34 degrees. All right, so now that we have that, and actually let me go ahead and write that down here. So this is 34 degrees. All right, now that we have that, let's go ahead and create the ratios. So I'm going to start with the ratio. I'm going to start with letter H. So letter H, little h, it's the side. We don't have it, so I'm just going to write little h divided by the sine of big H, which is the sine of 34. That is equal to, next letter, the order doesn't really matter, so I'm going to pick P. So little p is 17 divided by the sine of the angle that is right across each other. Okay, remember they all have to be right across each other. So that's going to be sine of 108. And that equals, now I'm going to do K. So little k, we don't know what that is, divided by sine of the angle that is right across that letter, which is angle 38. And that is my three ratios. And notice that we do have one of them. One of them is completely given to us, which means we can apply this. All right. So how do we do this? Obviously, we're not going to solve three ratios at once. We're going to pick two of them. I'm going to pick those two first to solve them. All right. So I'm gonna write them over here. Angle number 1, that's gonna be h over sine of 34 is equal to 17 divided by sine of 108. And now we're just gonna go ahead and cross multiply. So I'm gonna have 17 times sine of 34 equals, and now let's do the other pair, h times sine of 108. And now we're just simply going to get h by itself. So I'm going to divide everything by sine of 108. That goes away. You're left with h equals, and I'm just going to go ahead and put that into the calculator. So 17 sine of 34 divided by sine of 108. And I get 9.995, and it does want to the 10th. So that's a 9, which means I could probably round this to 10. So then I can say this is 10 inches. All right. Now I'm going to pick the other two. Always reuse the one that is given to you, by the way. Don't use the one with the 10 because we already estimated that one. So 10 is actually not the exact value of h. So number 2, we're going to use 17 divided by sine of 108 equals locate divided by sine of 38. And same thing, we're going to go ahead and multiply this. I'm going to cross multiply. So k times sine of 108. Doesn't really matter which ones you do first. And then 17 and sine of 38. So that's going to be 17 times sine of 38. And now let's just go ahead and get k by itself. That goes away. And k is going to equal to, once again, 17 sine of 38 divided by sine of 108. And I get 11.004, which is just going to be 11. Since we're going to be rounding to the nearest tenth, but the nearest tenth is 0. I mean, 0, so I mean, I can't really round up or down, so 11. All right, so there's my h, and there's my k value. Cool. All right, next one. So now notice, once again, we're going to solve this triangle. We can figure out angle P, actually, by just doing 180 minus those two angles, so 36, and then minus 113. And I get 31. So this is 31 degrees. And in this case, I need little k and I need little h. And let's just go ahead and create our ratios. So I'm going to start with P. So this is 14 divided by sine of 31 equals, I'm going to do H next. So sine of 113 equals, we don't have K, so little k divided by sine of 36. Remember, always do the side and the angles that are right next across each other. Okay, so this is the ratio that is given to me, and that's the ratio that I'm going to be using to find h and k. So let's start with those two. 14 divided by sine of 31 equals h divided by sine of 113. And same thing, go ahead and cross multiply. So this is going to be h times sine of 31 equals 14 times sine of 113. Go ahead and get h by itself. We're going to divide sine of 31. That's gone. And you're left with h equals, let's go ahead and put that into the calculator. Make sure that you're putting this into the calculator yourself, just to double check that you're actually getting that answer. So this is 14 sine of 113 divided by sine of 31, and we get 25.021. Again, we're gonna round to the nearest tenth, which would be, we can look. I mean, there's a 2 and a 1, so I mean, really, we can't really round anything. So I'm just gonna leave it as 25.02. Okay. All right, next one. So I'm going to use the next ratio, which is going to be the red one and K. So next one is going to be 14 divided by sine of 31 equals K divided by sine of 36. Same thing. I mean, I'm going to kind of skip the work here. I think at this point, you kind of know what's going to be. You can go ahead and do that work yourself just for the sake of time. I'm just going to kind of speed it up a little bit. So K is going to be equal to 14 times sine of 36 divided by sine of 31, which essentially gives you, so 14 sine of 36 divided by sine of 31. So K is equal to 15.977. So I'm gonna look at that number right there, which means I can round up the 9. So essentially, I could probably say this is 16. Cool. All right. Let's go ahead and turn the page over. Now we're gonna finish up with this one, area of an oblique triangle. This is pretty easy. This is also multiple ratios that are gonna be pretty much the same. So the area of an oblique triangle can be found by this equation, and basically all of that is the same thing. So area equals 1/2 2 sides BC times sine of A, or 1/2 of side AB times sine of angle C, or 1/2 of A times C times sine of angle B. What that means, those three things are the exact same thing, okay? All you really need to know is that in order for you to find the area, you need to find 2 sides, and you need you need to have 2 sides, and you need at least 1 angle. So 1 angle. But once again, all of those 3 are pretty much the same thing. So which makes this a really easy example. So objective 3, we're going to find the area of an oblique triangle using the sine function. Find the area of a triangle having 2 sides of length 8 meters and 12 meters and an included angle of 135, round to the nearest square meter. All right, so nearest square meter. So whole number. So area equals, again, it doesn't really matter which ones you use. I'm just gonna say BC sine of A, even though I don't know if that's a B or that's a C. It doesn't really matter. So we're just gonna plug in the values. So this is gonna be 1/2 times the 2 sides, which is 8 and 12, times sine of whatever angle is given to you, which in this case is 135. And you're simply just gonna put that into the calculator. So this is 8, 12, and then sine of 135. And we get 33.941, which we can probably round to 34. And that is for today.